You give an AI agent a tool, a database, and a clear task. You ask it to do real work. But halfway through the job, it drops everything and starts completely over. It rereads documents it summarized just seconds ago. It asks the user for information the system already possesses. And before any actual, useful work gets done, it blows through its token budget. The underlying cause of this amnesia is the architecture most of these systems are built on. Classic retrieval augmented generation, powered by vector search. Vector search was built for a specific, single-step job. A user types an FAQ into a chatbot, the system finds 3 mathematically similar paragraphs, and it writes a quick answer. It was never designed to run long, multi-step agentic workflows. Deploying a single-step memory system for an agent trying to execute a complex task leads to stalled operations and a waste of compute resources. Pinecone estimates this continuous loop of rediscovery can eat up to 85% of an agent's compute. The companies that built their empires on vector search are starting to sound the alarm. Pinecone recently shipped a new product with a blunt message. Vector search is not enough on its own to power agentic workflows. They are far from alone. Google made knowledge architecture the primary headline at their Cloud Next event. Over in Europe, SAP committed more than €1 billion to AI infrastructure. Their investment bypasses chatbot and language model development to focus entirely on memory. Every serious infrastructure vendor is racing to solve this memory deficit because current tools require agents to reassemble their own context on every run. Classic vector search flattens complex, structured documents into a single stream of raw text chunks based on word similarity. But when you strip away physical structure, the system treats a critical risk factor section exactly the same as a general summary paragraph. Think about a legal contract. A single clause might look relevant to an agent's query, but the definitions section 40 pages away can change what that clause legally dictates. If the system just grabs the closest text chunk, it loses the legal reality. This is why approaches like page index are gaining traction. Instead of mathematical text chunks, they build a hierarchical tree of the document, mapping it out like a detailed table of contents. The AI reasons through the structure of the tree itself, abandoning vector similarity. Relying solely on text similarity ignores the structural context an AI requires to return a factually correct business answer. Feed a business spreadsheet into a language model as text, and the numerical alignments break down into a chaotic jumble. You cannot calculate forecasts from text. SAP is backing tabular models, allowing an agent to reason over data directly in its native grid format. Then there is data that is relational, complex questions about which suppliers connect to its shipments. Microsoft is pushing into GraphRag to map out and trace these exact mathematical relationships between disparate entities. If model context windows keep getting larger, can't we just dump all this material into the prompt and let the AI sort it out? A massive context window does not mark which source is authoritative. It doesn't enforce access permissions, and it treats current and stale data as equal. This is context rot. Performance degrades as the window gets larger and more cluttered. Agents require appropriate, structurally preserved context to reliably execute tasks. This brings us to a mistake that derails agent projects, shopping for a specific database vendor before analyzing the required data structures. The database dictates the shape of what you can retrieve. If you choose the vendor before you know what your agent needs to do, you artificially constrain the agent to whatever that database is good at. The first step is writing a strict contract. Figure out the exact knowledge bundle your agent requires to do its specific job. Watch how this bundle forms. A customer support refund agent needs a specific set of inputs. It pulls the customer record from a tabular database, the refund policy from a structured document tree, and the prior ticket history from a relational log. Once you map out every necessary field, where it comes from, and who is allowed to see it, you can select primitives. You choose tools like vector searches, or semantic layers, or relational graphs, because they deliver your specific bundle. Building a memory system that respects native data shapes ensures consistent,